Dear colleagues, thank you to Earthly for inviting me to give this talk today about the different pumps that are implemented in their machine. I think these are the main strengths of the Earthly machines, the SPEEP, the Venturi and the Peristaltic pumps. But to be very honest, I didn't know actually the differences between these different systems in detail. So I tried to make up a kind of 10 minutes crash course for non-technicians. Let's start with the first one, the peristaltic pump. I would call them the small intestine among the pumps. Why? Because they simply work like a small intestine. You have got the aspiration line and the drainage bag. And as soon as you start to move the wheel, you always squeeze a certain volume through the aspiration line into the drainage bag. You have two different settings that you can adjust. The first one is the flow. The faster the wheel moves, the more volume you will squeeze into the drainage bag. I think that's clear. But what about the vacuum? How can you set up the vacuum? Well, actually you can't. There's only a kind of sensor up there measuring the vacuum. What you can set up here in the machine is the vacuum limit that tells you that the machine should stop at a certain amount or at a certain level of vacuum. And it's a bit of a difference. So the higher the flow, the more speed you will have in the anterior chamber, and the higher the vacuum, the more force you will have during the vacuum emulsification. So thank you to Richie, who prepared all these videos. This is just to show you that there's a kind of linear flow control. That means the more you squeeze, the more you press the pedal, the faster the wheel will move just in one direction. I think that's clear, and this is how the peristaltic pump works. The characteristics of the peristaltic pumps are that you have a very controlled and precise pump and movements in the anterior chamber, that you have high power without any turbulences. There's kind of delayed reaction. That means we're not talking about seconds, but milliseconds. The vacuum has to be built up, and it takes some milliseconds as soon as you've pressed the pedal. It's very precise, and you have to know that you always have to move the instruments. So you also have to move the phaco tip to the lens and not the other way around. Application examples are cortex removal or, for example, peripheral vitrectomy. This is just a normal, simple case of vacuum emulsification using only the peristaltic pump. And as you can see, it's a very controlled setting. You have a very stable anterior chamber, and you always have to move the tip of the phaco needle to the lens to build up a vacuum. And this is the big difference to the Venturi pump, that you always have to have occlusion to build up a vacuum. And I want to show you this other video prepared by Richie, showing you the normal setting, just to show you why you only have vacuum on occlusion. You have normal settings, 50 flow and 600 vacuum. If you don't have any occlusion and just press the pedal, you will see that the wheel moves all the time, but you have zero vacuum. And as soon as you have occlusion, and this is what Richie does here with his fingers, then the vacuum will rise up immediately to 600 and the wheel will stop. And this is what we preset with the vacuum limit, that the machine should stop at a certain level of vacuum. So only vacuum on occlusion. This is typically for the peristaltic pump. So to sum it up, the peristaltic pump has a linear flow control, which is measured in milliliter per minute. It has a vacuum limit of millimeter mercury. It has a very high power without any turbulences. It's a little bit delayed, and you always have to know you only have vacuum and occlusion. The second pump is the Venturi pump, and actually I would call it the vacuum cleaner among the pumps. Why? So technically seen, you press compressed air through a tube with a high lumen or a big lumen into a tube with a small lumen, and this will increase the velocity of the air immediately and cause a kind of negative pressure in the drainage cassette. So this is simply the effect of a vacuum cleaner. You again measure the vacuum power in millimeter mercury, and you also can define the Venturi effect. The higher the power, the more speed you will have in the anterior chamber, and the more power. The higher the effect, the faster the vacuum will rise. This video again shows you this actually a mixture of coffee and orange juice, that you don't need occlusion to put up a vacuum, and that's the big difference between the two pump systems. In a Venturi pump you always have to have occlusion, but in this case you don't really have to touch the liquid just to build up a vacuum. And this shows you quite nicely the big difference between the two pump systems. The characteristics of these pumps are that it's very direct, it's very precise, and it has a very logical response behavior. That means it's really like driving a car. As soon as you press the pedal, you immediately have a vacuum. Application examples are phaco without fishing. That means it's not the phaco tip that moves to the lens, it's the lens that moves to the phaco tip. And you can always use it for co-vitrectomy. And this is an example only using the Venturi pump. As you can see, there's much more turbulence in the anterior chamber, and all the fragments, they really move to the phaco tip. So if you're a rather experienced phaco surgeon, I would recommend just to use Venturi or the other ones, but just go for it. It's very fast and very simple. So to sum up the Venturi pump, again we have the linear suction control measured by millimeters mercury, and there's a direct ratio between vacuum and flow. It's approximately 10:1. It has a high force, it's very logical in the response, but you cannot directly control the flow, in opposite to the peristaltic pump. So this table shows you the differences between the two pump systems. There's the peristaltic pump. You directly control the flow and indirectly the vacuum. The main advantage here is that you have less turbulences in the anterior chamber. In a Venturi pump, it's the other way around. You directly control the vacuum and indirectly the flow, and this gives you much more speed. And now the idea was, would it be possible to combine both advantages? So to have less turbulence in the anterior chamber, but have a higher speed. And this is why they came up with the idea of SPEEP. This is nothing else than a peristaltic pump, and you directly set up or directly control the vacuum using the peristaltic pump, and rather indirectly the flow. What does it mean? So this is SPEEP. I would call it vacuum cleaning with the peristaltic pump. Again, it's nothing else than a normal setting of a peristaltic pump, but in this case you have a fixed speed of the wheel. Now the rotation speed of the wheel is fixed, and you only adjust the vacuum itself using your pedal. And the difference to the normal peristaltic pump is shown in this video. So we have the setting of 35 to 600. As soon as you press the pedal, the wheel will start to move immediately, very fast. So it will try to rise up the vacuum as much as possible. Real vacuum is only achieved by occlusion again, and this is what will happen immediately as soon as the aspiration line is occluded. So let's wait for Rich's fingers occluding. Here he goes. Okay, it stops immediately, and the difference now is that you can release the pedal to reduce the vacuum. And in this situation, the wheel will turn in the opposite direction. And this is actually not possible in the normal peristaltic pump function and mode. This is only possible in the SPEEP mode, and this makes the difference. What are the characteristics? It's very controlled, very precise. It has high power without turbulences. It's a little bit delayed. Again, it's only the peristaltic pump, but it's very precise. And as it's a peristaltic pump, always the phaco needle has to follow the phaco fragment. Application examples are, for example, cortex removal, polishing, peripheral vitrectomy, or retinal detachment. So this is a normal case using the SPEEP mode. As again, very controlled, very precise, and very fast. This makes the difference to the normal peristaltic pump. Again, we have fixed flow control measured in milliliter per minute. We have linear vacuum control only under occlusion, again measured in millimeters mercury. It has a very high force with low turbulence, less time delay than in the peristaltic pump, and more efficient control. And again, vacuum only under occlusion. So once again, these are the differences between the three pump systems. Actually, there are two systems and one mode. So in the peristaltic mode, we directly control the flow and indirectly the vacuum. The main advantage are less turbulences. In the Venturi pump, we directly control the vacuum and indirectly the flow, which makes it much faster. And in the speed mode, we directly control actually the vacuum and the flow is preset, which gives you less turbulences and more speed. Thank you for attention.